Okay, so we're looking at 5.1 doing absolute value equations. So these are just some basic equations that use absolute value. So when we're talking about absolute value, the absolute value of x is the non-negative value of x without regard to sign. So basically repeating itself a little bit there. But really when we're talking about absolute value, it's the distance from 0. So if we think of a number line, and we have 0 right there, and we have -5 here, and +5 there, taking the absolute value just says, well, how far away, if we measure just distance right here, that's 5 away. But this right there, that is also 5 away. So really we're just measuring how far away it is from 0. And so the way to think about that is that whatever the number is, if I take the absolute value of it, it's going to make it positive. So taking the absolute value of just a 5 really doesn't do anything to it. It just works out like it normally would. So what that means for us is anytime we solve absolute value, we are going to be able to, when we've got just the absolute value left, or the stuff inside the absolute value bars, we'll solve it as the positive and the negative. So right here for number 1, what that means is we're going to work this out 2 different times. My first option is to just do the normal 5x equals 40. And so half the time it's going to work out to where it doesn't matter, you don't really need it. You don't need the absolute value bars. And so we divide by 5, and that means x would equal 8. And then we're going to work it out where 5x equals -40. Because if I got a -40 inside the absolute value bars here, then that's going to also turn positive and equal 40. So I divide this out, then x could also equal -8. And so writing it as a solution set, we just say that x could be -8 or +8. And that would be our answer. We've got 2 options there. Now, don't think that we can just get one answer, the 8, and say it's positive or negative, because that's not going to be the case most of the time. This is only because I've just got multiplication going on here. So when I divide, the positive versus dividing the negative is just going to give me the same thing with the opposite sign. Okay, looking at the next one, half the time it's going to work out normal. So d plus 1 equals 8, which means d would just equal 7. And then the other half of the time, be d plus 1 could also equal -8. And so if I subtract that here, you already see a little bit of the difference, that this one is going to equal -9. So those are kind of our 2 options there, either 7 or -9. And so we'll write that as a solution set, that it could be -9 or it could be 7. Either one is going to give us that correct answer. Okay, and in the same way here, continuing to work it out in the same way, I have -2x minus 5 equals +17, or we'll do -2x minus 5 equals -17. So that takes adding 5 to both sides to be 22. -2x equals 22. And when I divide by -2 on both sides, x is going to be -11. Then for the next one, we add 5 to both sides. And -12 equals -2x. Divide by -2 there, and we're going to get x equals a +6. And so whether I put in -11 here or +6, both are going to work. Both will solve it out. And so my solution set here would be -11 and 6 are the two things that would work for us. And really what's going on here is we've graphed this out. We've graphed all these out, and so we could say this is the absolute value of -2x minus 5 equals y. And so if we were graphing that out, it'll look something like dot here at 5, or I guess it'd be 2.5 if we were working that out. Or it might be back the other way since that's a negative actually. But wherever it ends up, the graph is going something like this. And so way up here, there's a line where y equals 17. Because we're setting that equal to 17, and so what happens is you've got two spots on there where that's going to hit the graph, and so that's why we have two answers versus just a straight line where it would only hit where y equals 17 once. So just be kind of thinking about it works because we have that graph, and so we are able to solve it as a result. Okay, now when I've got stuff outside of the absolute value bars, we're going to get rid of all that first. So kind of like when we're solving for x, we move everything that doesn't have an x over to the right side, leave the variable on the left side. It's going to be the same with the absolute value bars. So anything that is not in the absolute value bars, I will move over to the right side before I do anything else. So that means right at the start, I just subtract 2 from both sides to get the absolute value of c equals 10. And I try to draw my bars really long because otherwise there's always a chance of mixing it up and thinking it's parentheses or something else. And so for that, c is just going to be either -10 or +10. And so we'd write that as a solution set -10, +10. And that would be our answer. Those are the two values for c when y is equal to 12. Okay, on the next one, doing the same thing. This -2 is on the outside, so divide everything by -2, which gets us the absolute value of x plus 3 equals a +7. And so we'll work it out as that, and we'll also work it out as x plus 3 equals -7, because that will meet the requirements for our absolute value. So if we subtract 3 from both sides, it gets me x equals 4. And same thing here, we subtract 3 from both sides, we get x equals -10. So solution set again, -10 or 4. And we've got our answers. Okay, last one, we're putting a couple of steps together here. So there's also the, when we're looking at this, we really want to be able to multiply this 7 into the absolute values, but being that it can change from a positive to negative in here, and anytime it comes out, it'll be only positive. You can end up having some troubles if we do that. So, got to get rid of everything outside by moving it over. So that would be adding 6 to both sides. Should be 119 equals 7 times the absolute value of 4x plus 8. And I divide everything by 7. And when I do 119 divided by 7, it's actually going to be 17. And so we have the absolute value of 4x plus 8 equals 17. And this is when we split up into our 2. So 4x plus 8 equals 17, or 4x plus 8 can equal negative 17. So subtracting this, we'd get should be an 8, huh? So 4x plus 8, and we subtract 8, we get 9. So 4x equals 9, or x would just equal 9 over 4. And if we subtract here, negative 17 and negative 8 would give me a negative 25 equals 4x. Divide by 4, x equals negative 25 over 4, which we really want to simplify because we see 25 and 4 and say, oh, 25 times 4 is 1. But these two numbers actually don't simplify. None of them do. So our solution set here at the end would be negative 25 over 4 and 9 over 4. So try and keep in mind those graphs as we look at this. So looking at this one being something like that and saying, well, 113 would be way, way, way up there. But thinking where y equals 113, that's what we're really finding is those 2 points on that graph. And so there are some graphing things you could do to solve that, but this works out pretty quickly. You've got some stuff you can put in the calculator to help you out on that. And so that's your absolute value equations.